Hello, and welcome to a little video about the horizontal translations of exponential functions. Now, like last time with the vertical translations, I just want to remind you that part of the exploration we did was on our calculator, and unfortunately, I cannot screen capture both in the same video. So if you need some help with that, you just let me know, and I can help you in class, and so can any of your other teachers if you are not one of my students. Okay, so here are three functions that we're going to look at. The most basic one is h of x, just like last time. Now we have a v and we have w. V has a plus 3 in the exponent. W has a minus 3 in the exponent. What that means is we are taking for, whoops, I don't know why I wrote h. We are taking, I know it says wx here, but we're taking v of x. And it's going to be h with a plus 3 inside its parentheses. For w, it's going to be h with an x minus 3 inside its parentheses. Why is it inside? Well, that's because the plus and minus are inside the parentheses of the exponent. When we did up and down, we had something outside. This one is inside. Now, we did, on the calculator, we graphed v of x, and we saw that this plus 3 actually moved us left. And we saw that this minus 3 moved us to the right, which is so counterintuitive, but it's consistent. In all of math, a plus moves you to the left, a minus moves you to the right. And here, let's sketch what I had on my calculator and what you did too. So we had an h of x, rough sketch, obviously. Our vx, when we graphed the 2 to the power of x plus 3, this is what we ended up with. We ended up with a graph like this. And then we graphed w, and w ended up like that. Their tails, that bottom part, all merged. Because we didn't move up and down, we just moved left and right. Okay, now, how do we compare it? What do we notice? Well, Vx moved left of h of x, and W moved right of hx. So we're just rewriting the same things in many different ways because they appear in many different ways to us. Okay, for number 4, we're going to complete this table. Now, when we are moving left or right, let me draw this little graph here. When we're moving left or right, what's changing, the x's or the y's? The answer is our x's. Now, this looks so weird because the plus 3 here, it's actually moving to the left. So we need to subtract 3 when we do this one. And this minus 1, even though it says minus, we're actually moving to the right. So we add 3. Very weird. I know it is. It always is. And it is like this for every single function you ever run into. If we're moving to the right, you're subtracting in the function itself, but to the points you're adding. And if there's a plus 3 in the function, you're actually subtracting 3. Okay, now the nice part here is that our x's are whole numbers. Phew. All right, let's do this. Let's do the left one first. Negative 2 minus 3, negative 5. Negative 1 minus 3, 0 minus 3, 1 minus 3, and 2 minus 3. So there are our answers. Next, let's move h to the right instead. Negative 2 plus 3 is 1. Negative 1 plus 3, 0 plus 3, 1 plus 3, and 2 plus 3. So all of our x's got bigger. And that's exactly what we're going to write in number 5. We are going to write that for Vx, which is left, x's got smaller by 3. Wx, which was to the right, our x's got larger by 3. And it's opposite. It's so opposite. Because for the left, even though it looks like there's a plus and right looks like there's a minus, we're subtracting for left and adding for right. And let's write that down in math language for number 6. So if our original points are x, y, when we move to the left, we're subtracting 3. Whoops, I don't know why I wrote a y there. That's silly. Subtracting 3, y stays the same. Again, reminding you, the plus means minus. And when we're moving to the right 3, it looks like we're minusing, but we're actually adding. Okay, so that's number 6 is number 5 in math, right? Smaller by 3, larger by 3, smaller by 3, larger by 3. For number 8, let's make some generalizations. We're going to talk just about the domain and range, not the asymptote. The domain was our x's. What did the horizontal translation do? Did it change them? Sure did. Changes the domain. Now the ranges are y's. Did our y's change when we did the transformations right and left? The answer is no. Horizontal transformation didn't change the range. Okay, that's all that we did for this lesson, and we did a little bit of classwork with it. If you have any questions, feel free to ask myself or whoever's helping you out with this. Have a wonderful rest of whatever day it is for you. Bye!